Alright, now let's understand timer operation T off, which is typically known as off delay timer. Okay, the last timer was T on and this is T off. So it has a slight difference than the T on. So let's see what's that, although the block diagram looks same. So in T off timer, it says the T off timer sets the output to on and then reset the output to off after a preset time delay. So here's the difference. Once you turn on the input, the output will be on immediately. But if you turn off the input, the output is off after time delay. Okay, so we'll understand that in a timing diagram. So let's understand the parameters, which are pretty similar. We have a data block name, then you have an input signal, preset time, current time, and the output signal. The only difference is in the timing diagram. So have a look. It says if the preset time is 3000 millisecond or 3 seconds, which is over here. So if input goes on, the output is on immediately, which does not happen in T on. So that's the first difference. Output is on by following the input. But now if input is off, then your time will start. At this point, your time will start, which is the preset time. And after 3 seconds, the output is off. So this preset time you can vary by giving the signal to PT, by changing the parameter at PT. So that's the off delay. The off operation is delayed. This is what you call off delay. Okay. So here, let's understand here what's happening here. When you turn on the input, the output is on. When you turn off the input, the time starts. Now, if this time is less than 3 seconds, less than PT or 3 seconds, and you turn on the input again, the time will start again. Because the timer will reset, this timer will reset ET, and it will again, when you turn on the input again, it will again load this time to ET. So it will again start the time. So now the total time is more than 3 seconds. Unlike timer pulse. In timer pulse, this does not affect the operation, but here it does affect. This is what it says as did you know fact. It says changing PT has no effect while the timer runs. So if you change the PT, this will not affect the timer operation, but changing into true while the timer runs, reset and stop the timer. Okay, it will reset the timer, but it will not. This is incorrect. It will not stop the timer, but it will again restart the timer. It will reset, and here instead of stop, it is initialize. It initialize the timer. Okay, I apologize for this inconvenience. Sometimes, you know, people make mistakes. So here it's not stop, it's initialize. So I will write the short word init. Okay, init. So it will initialize the timer again with 3 seconds. So let's have a look of this timer in our Siemens TIA 1200. Now this is the last application. I'm going to delete these letters and just check the PT T off. Now the quickest way to change T on to T off is just double click that and change this to T off. The rest everything is fine. Okay, this is 3 seconds. Now let's download this logic and see the results. Okay, so monitoring on. Monitoring is on. Here is your PLC. Now, okay, initially I need to stop the PLC first and run the PLC and turn off my input because my input is on from the last operation. Okay, now everything is reset. Inputs are off and outputs are off. Now I will turn on my input. Okay, so when input goes on, you can see that the output is on and there is no time operation, nothing happening, only the output is following the input. The time will start the moment I turn off the input. So this timer get energized if you have high to low, your 1 to 0 transition at the input. So the moment it gets 0, the time will start and you will see the output will be off after 3 seconds. So once I turn off the input, timer started, and after 3 seconds output goes off. This is the off delay. It means it has a delay operation in the off operation of the output. So let's start again. I will turn on the input and I turn it off, and it will take 3 seconds before the output goes off. Now if I turn on the input within this 3 seconds, what will happen? Let's see. So turn on the input again, turn it off, and I'll turn it on. So if I turn it on, the timer goes back to 0, and it will reinitialize if I turn off the input. So timer 3 seconds is more added. So this is what it says in my did you know fact, that if you turn on the input within the time, timer will reset goes back to 0, and it get initialized again. So that's why I use the word initialize to make it more sense. Like this, goes back to 0, initialize for 3 seconds, and the output will be off. So this is the simple application of timer off, T off. Now let's have an example which will make it more clear. Okay, let me turn off my pointer. Yeah. Okay, it says write a logic to latch the output for 5 seconds with a momentary input signal I0.0, which is pretty much similar. So here, because we have used the word momentary, I have used this P here, because for momentary we just need a pulse. Okay, so it's pretty much similar. When you turn on the input and when you turn it off, you will have this pulse here which will activate my timer, and you know that when this pulse is on, the output is on. At this point, let me take another color. Yeah, at this point, this particular point, the output will be on. Okay, but when the pulse goes off at this point, or at this point, the timer will start for 3 seconds. Okay, when the 3 second goes off, then this lamp will be off. Okay, so the timer get energized at this part, but the output is on at this part. That's the difference. Okay, so this is pretty much similar to what we have done. We have done for 3 seconds, and here it's for 5 seconds. So here instead of 3, there it will be 5 seconds. Okay, so now if you see the FPD solution, it's pretty much similar. You have a pulse trigger here, so this is P, and this address is same, the tag is same. This goes to the input of timer T off, and the timer is 3 seconds again, this which should be 5 seconds anyways, and the output goes to my lamp. So this is a PDF or FPD solution for this ladder logic. Now we have a very interesting exercise in which we may have to use both the timers T on and T off. So let's see what it says. Start a motor. We have an output Q0.0 with input I0.0, 0 to 1. So if the input goes from low to high, the output should be on immediately. And after 10-second delay, start a motor 2, Q0.0. Okay, so first your output Q0.0 is on with the input I0.0, and there is a delay of 10 seconds. So this is an on delay for motor 2. So we have to use T on. So this motor will be on after 10 seconds of motor 1. So there's an on delay. Correct. Now stop the motor Q0.0 with input 1 to 0. So if the input goes off, motor 1 should be off immediately. So there is no delay in turning off the motor 1 with the input. And after 10-second delay, stop the motor 2. So what you can see here is motor 1 is getting start and stop with input I0.0. Okay, but motor 2 has an on delay and it has an off delay as well. Okay, so if you understand my both videos of T on and T off, you can try this logic. Okay, and you can take a pen and paper and try this logic. Otherwise, of course, I'm going to show you the solution. The solution is here. Let's have a ladder logic solution. The input starts the motor. Okay, let's have a pen here and a color with green. So when I turn on my input, the output should be started immediately, so my motor will be on. This will be on. Perfect. This is what it wants. Motor should be on with 0 to 1 signal at the input. So this is 0 to 1. Motor is on. And when the motor is on, the same tag is here. We have a bit. So I will turn this one green as well. And we have a 10-second T on, timer on. So this will be on after 10 seconds. So I will use it like this. Okay, motor 2 is on after 10 seconds. That's fine. And when this motor is on, we have a tag bit here. This will be on. Okay. And because this motor 1 was on, this will also be on. I hope this makes sense. And this is my Q. This is timer off. Okay, which means this Q will also be on. Okay, but this Q is on because my motor Q output is on. So when you start the input, immediately this will be on, which will turn on this bit motor 2, which will turn on this bit motor 1 as well. Sorry, not motor 2. This motor 1 output is on, then this output is on, which will turn on my bit as well. But this motor 2 will be on after 10 seconds. So after 10 seconds, this is on and this is on. Now if you see here, this has been latched. Okay, so this motor 2 is on and latched. Now what will happen? If I turn off my input I0.0, so I will use an eraser. If I turn off this input, this signal will be off, this signal will be off, motor 1 is off, this motor 1 is off. Okay, so this timer signal will be off. Let me turn off this as well. And this will be off. So now this is off timer. If the input goes off, now this timer will start for 10 seconds. And then it will go to 9, 8, 7. And after 10 seconds, this Q will be off. So this Q will be off, which will break the signal, which will turn off my motor 2, which will turn off my motor 2. And everything is off. Okay. So we have an off delay of this motor 2 using T off, and on delay of motor 2 using T on. Okay, I hope this makes sense. Otherwise, let's try to understand that in our Siemens TIA. So I'm going to replicate this logic. So what we have with the start input, we have motor Q0. So I'll just replicate the exact logic. So I will change this to start. Let's name it as motor 1. Okay, now after 10 seconds of motor 1, second motor is on, so I'll take the same tag here. This goes motor 1. Now we have a delay, so of course we need a timer of 10 seconds. So I'll use timer 1. 10 seconds is 10s. I don't need ET. And this output goes to my second output, which is my second motor, Q0.1, and here I will rename the tag motor 2. Okay, now what? We need to latch this motor because we are going to turn off the motor 1. So we need to latch this. So to latch this, I will take a parallel here and a contact here. So this will be same to motor 2. Motor 2. So I will take T off later. Okay, now what will happen? We need to turn off a timer off using my first motor 1. Okay, so I will take another bit. This will be motor 1. So this motor 1 is going to energize my timer off. So let's have a look at the example. You can see here, this motor 1 is going to take to timer T off. Okay, so let's go back to, so here we're going to take T off. This will be T timer or T2, whatever you want to give. Oh, I'm sorry. Let's put it here. Yeah. Timing as per the question 10 seconds, and we don't need to use as output. So you can leave this branch open. Okay. Now we need to put here for latching because we need to turn it off. So this goes off when this timer goes off. So when this Q goes off. So we will take an NO contact. And this address will be timer 2 Q dot. So you can use timer 2 data block, take the Q contact, and you are done. So everything is fine. So this is the logic of your on delay plus off delay for the timer operation of a motor. So let's download this logic and have a look of what we want to achieve. And you will be pretty much clear with this live demonstration because we have a 10-second delay, so it's easy to monitor both things, what is happening. So the logic is downloaded. I'm going to monitor it and show you parallelly what's going on. Okay, well, I can maybe maximize it. Okay, this is fine. Right, so initially I will turn on the input, output will be on, and timer will start for 10 seconds. So let's have a look. I'll turn on my input. So my output goes on immediately. Timer starts, so it's 3 seconds because it's on delay. So this will be on after 10 seconds. And if you see here, timer 2 is already on because it's off delay and this bit is on. So my motor 2 is on. So what happened right now? Input is on, which turns on the motor 1. After 10 seconds, motor 2 is on. And because this motor 2 is on, this bit is also on. This is same tag. And this bit is on because this is motor 1. And this timer is on because this is off delay. But if you see, there's no time does not start because it's an off delay. This time will start when this goes off. Okay. And this bit is on because this is Q. So my output is latched. All right. Now, if you assume it is a practical application, the operator has turned on the input and the second output is on after 10 seconds. Now, maybe after an hour or after maybe 2 hours or few hours, he wants to turn off the outputs. So he will turn off this input here, which will turn off my motor 1 immediately because this is connected to motor 1 directly. When this goes off, this will be off. So this timer will be off, but this will remain on because this is latched here. But parallelly, when this goes off, this will also goes off, which will start the timer. This is what we want to see now. So let me just align it a little. Yeah. So just notice when the motor goes off, this timer will start, which will break this contact. Okay. So I will turn off the input. Now you can see the timer starts, and this is off and this is off. So this will break once the timer complete. So after 10 seconds, this will be off and output will be off. Okay, so we have an on delay plus an off delay in output Q0.1. Let's have a look again. I will turn on the input. So Q0.0 is on, 10-second delay, 0.1 will be on. Right, now if I turn off my input, immediately motor 1 will be off, and after 10-second delay, second output will be off. Right, this is what we want, this is what was asked in the objective. So that's how we can use combination of T on and T off to achieve the objective. Okay, and if you want to see the same operation in FPD, this is pretty much similar. So you have motor 1, which is on immediately with I0.0. And now with this output Q0.0, you have a time T off. Now this part of the logic is here. This motor, this is T off, okay? And now with motor Q0.0 is starting the timer T on. This part of the logic is here. This is here. 0.0 is starting the timer, and this is ORed with 2 bits to motor Q2. So you see here, this is an OR gate. It's OR operation with 2 bits which are in AND, motor 2 Q0.1 and T off.Q. This part is here. Okay, this is an AND operation which is going to motor 2. So this AND operation is going to motor 2. So this is having 2 outputs coming from this logic and coming from this logic. So this is your solution in FPD. So let's review what we have learned. T off is used to generate off delay only. Okay, when the input goes from on to off, timer starts and you have an off delay. The parameters of T on are stored in data block, which can you access anywhere. Okay, so just because of the continuation of this presentation, the parameters of T off. This is much similar to T on because both parameters are stored in a data block, which we can use anywhere in the logic by using specific addresses. Okay, thank you for watching, and I'll see you in the next video.